Okay, guys, what we're going to be covering today is Chapter 9, Section 4, which deals with the volume of prisms and cylinders. Okay, when we're talking about volume, we're talking about the amount of stuff that can fit inside of a three-dimensional space figure. So maybe think of it this way. If you have a nice uh, cylindrical cylinder coffee cup, because you guys love drinking coffee, um, a coffee cup uh, that that is in a cylinder form. We're talking about when we say volume, how much coffee could we fit in that cup? Or if you have a nice, I don't know, a cylindrical water jug, how much water fits in that jug? So when we just say volume, we're talking about amount of stuff that fits inside of a three-dimensional object. Okay, so specifically today, amount of space inside of a prism and cylinder. Okay, so number one, the volume inside of a prism. 1 and 2 are prisms, okay? To find the amount of space inside of a prism, it's going to be found by taking the area of the base times the height, okay? So first we need to name number one. It's a rectangular prism, okay? So we need to find the area of the base times the height, and that'll be the space inside of this rectangular prism. How I like to say it, though, in terms of finding volume, is what shapes are we stacking? Okay, are we stacking squares? Are we stacking rectangles? Are we stacking triangles? Are we stacking circles? Or whatever shape we're talking about, what are we stacking and how high are we stacking them? So that's how I'm going to explain volume. Instead of saying volume is area of the base times the height, I'm going to say what are we stacking, what shape, and how high. In other words, in number one, if I say what shape are we stacking, well, we're stacking rectangles. Why are we stacking rectangles? Because the base down here is a rectangle. Okay, so we're stacking rectangles. How high are we stacking the rectangles? We're stacking the rectangles 4 miles high. Okay. What literally, like the amount of space inside of this rectangular prism in number one is we're literally saying how many of these 9 by 11 rectangles can we stack on top of each other all the way to the top. That's why I'm saying stacking what shape and how high. Okay. So the volume of this rectangular prism, what shape are we stacking? We're stacking rectangles. Okay, so 9 times 11, because that's the area of the bottom. So we're stacking rectangles. How high are we stacking them? 4 miles high. Okay, so the volume, or how many rectangles we could fit in this prism, is going to be 99 times 4, okay, which is going to 396. Oops, sorry, 396 cubic miles. Okay, surface area and lateral area, or area I should say, is in square. The degree is 2, but it's cubic when we talk about volume. So um, the volume or space inside of this rectangular prism is 396 cubic miles. Okay. Number 2, all the dimensions are 12, so you might call this a cube, or we can call it a square prism. Okay. So I would ask my students, what are we stacking? Hopefully they would say, hey, we're stacking squares. And I say, how high are we stacking the squares? We're stacking them 12 centimeters high. Okay, so the volume is going to be, we're stacking squares. So it's going to be 12 times 12. And how high are we stacking the squares? 12 high. Okay, so 12 times 12 is 144. And 144 times 12 is going to be 1,728. So it's going to be 1,728 cubic centimeters. Okay, so again, in number 2, when we say the space or volume inside of this square prism, what we're really saying is how many squares can we stack on top of each other all the way to the top. Okay, so in this case, we're stacking squares. We stacked them 12 high. Moving on to a triangular prism. So we just did on the first page how to find the volume of a rectangular prism. We're stacking rectangles, and then in number 2, we're stacking squares. Okay, here, this is a triangular prism because the bases are triangles. Okay, there's one of the bases. There's the other base. So this is a triangular prism. So we're talking about volume here. What are we stacking? Well, we're stacking triangles. How high are we stacking these triangles? 10 centimeters high, actually. So we're stacking triangles 10 centimeters high. Okay. What I would like to do before we do this is I'll pull out one of the triangles since we're stacking triangles. Okay. That's 3 centimeters, 4 centimeters, and the hypotenuse to the right triangle is 5 centimeters. So we're stacking triangles. If we're stacking triangles, okay, the area of a triangle is base times altitude divided by 2, or maybe your teacher will say base times height divided by 2 times how high we're stacking these, which is 10 centimeters high. Looking at this red triangle, which is one of the bases, since we're stacking triangles, the base is 3, the altitude is 4. I want to point out that often students will use the 5 as the base or the height of the triangle. I want to remind you to find the area of a triangle. It's always the base and the height of the triangle will always be the two segments that are perpendicular to each other. So the 3 and the 4 segments are perpendicular, and that's why they're the base and the height of the triangle. So we're stacking triangles. So 3 times 4 is 12. Half of 12 is 6 times 10. So it's got to be 60 cubic centimeters. 60 cubic centimeters is the volume of this triangular prism. So again, we were stacking triangles, and we're stacking them 10 centimeters high. Maybe you want to think laterally here, stacking the triangles laterally. Okay, let's go on to number 4. And number 4, this will be called a triangular prism. Okay, and I also want to draw one of the triangles. Okay, so this is 12 inches, then this is 9 inches, we got 6 inches, then the altitude of this triangle on bottom, this segment, that's 4.4. So I'll put an arrow here. The altitude or the height of the triangle is going to be 4.4 inches. Okay, I'll highlight the triangle I just redrew. It's down here on the bottom. We see that? Okay, so to find the volume or the space inside of this triangular prism, we're stacking triangles again, and we're stacking them 4 inches high. Okay, so we're stacking triangles again. Now we're stacking them 4 high. Okay, well I'm looking at the base of the triangular prism, and I redrew one of the triangles off to the right in blue. So the base of that triangle is going to be the 12 inches, and the altitude to the triangle is 4.4 inches. Okay, and I want to point out that in any triangle, the base and the height, which I'm calling altitude, the base and the height of the triangle are the two segments that are perpendicular. That's why we're using the 12 and the 4.4 here. Okay, and we're still stacking 4 high. Okay, so we got 12 times 4.4. That's going to give us 52.8. So we got 52.8 divided by 2 times 4. Half of 52.8 is going to be 25, 26.4. So it's going to give us 26.4 times 4. Okay, if we quadruple 26.4, we're going to get 52, 104, 104.8, 105.2, 105.6 cubic inches. And I need to check my mental math here because I did that real quick. 26.4 quadrupled. I'm pretty sure I'm right. 105, very good. So the volume, or we were stacking triangles here. How many triangles could we stack in there? 105.6 cubic inches of space inside there. Moving on to cylinders now. Okay, so for cylinders, we're stacking circles. Okay, so for cylinders, we're stacking circles. because you got the base of a cylinder as a circle. How high are we stacking these circles in number 5? We're stacking them 11 meters high. Okay, so our volume is going to be stacking circles. See, the area of a circle. How high are we stacking them? 11 meters high. So the volume here is going to be the radius squared, which is going to be 7 squared times 11. Okay, so we want to take 7 squared, 7 squared, which is going to be 49. Okay, so we got 49 pi times 11, which is going to give us 539 pi cubic meters. Cubic meters. So literally stacking circles on top of each other all the way to the top. How much space fits inside of this cylinder? 539 pi cubic meters. Remember, if you're ever using an answer key attached to one of these worksheets, most likely the answers are not in terms of pi, so you would check your answer here by taking 539 and multiplying it by 3.14, which will give you the approximate answer if it is not in terms of pi. Okay, and number 6, it's a cylinder. So the volume or space inside of this cylinder, okay, for any cylinder, I should say we're stacking circles. So again, we're stacking circles. How high are we stacking them here? 11 centimeters high here. Okay, so the radius of the circle is 11 centimeters. So it's 11 squared pi times 11. So 11 squared is 121. So we got 121 now times 11. Okay, we're just going to give us 1,331 pi. Got the units, cubic centimeters. Cubic centimeters. So the volume or space inside of this cylinder is going to be 1,331 pi cubic centimeters. If you need an approximation, you would take 1,331 times 3.14. Okay? There's the answers on the back of the work we were doing. You'll notice none of those answers are terms in pi for the ones that have a pi symbol in it. Therefore, we talked about how to approximate that. Thank you for tuning in today.